Modeling with quadratic functions. This is part 1 of 2. We're going to have to use this function, and we looked at it a little bit yesterday, and that is h of t equals 1/2 gt squared plus v sub 0 t plus h sub 0. These sub zeros in here are just another way of identifying a variable. Remember before when we wanted to pick variables, and let's say if we were talking about somebody's age, you could use A. What if you had two people in a problem? If you make one person's age A and the other person is B, it can get kind of confusing. You can use A for both people, as long as you put the little subscript number at the bottom of the variable and make it different than the other person. That's what's happening here. V sub 0 means just the initial velocity, and h sub 0 means the initial height. Those could have been 1 or 2, but they're 0 because it means that's where it started at. Initial velocity, initial height. When you evaluate a function like this, you're coming back with an answer in terms of height. Height as a function of time. In terms of t. The G stands for gravity. Now gravity has two different amounts. It depends on if your problem is in terms of feet or in terms of meters. If your problem is in feet, you must insert a negative 32 in for G. If it's in meters, you must insert a negative 9.8. The T stands for time in terms of seconds. The V stands for velocity. The V stands for velocity. It's the rate of change in terms of feet per second or meters per second. The initial velocity. And it's multiplied against t, so don't forget the t is in there as well. And you have the initial height of the object, where it's being thrown from. If the person is standing on the ground, from what height is the object being thrown? The ground in terms of a number is what? 0. And if they're on a building that's 75 feet up, then it's 75 feet. If your equation or if your problem is in terms of feet, then so must your equation be as well. So here's the general form we already wrote down. But you have to insert a negative 32 for G if your problem is in terms of feet. So there's your negative 32 going in. Multiply it by a half to get a negative 16. So this is the function you want to use if the problem you are given is in terms of feet. If your problem is in terms of meters, then your function must be in meters as well. So instead of putting in a negative 32 for G, you would have to put in a negative 9.8 for meters per second squared. So there's your negative 9.8, and multiply it by a half to come up with negative 4.9. This function is what you should use if the problem you are given is in terms of meters. In this problem, Chris stands on the edge of a building at a height of 60 feet. Don't even finish reading the rest of the problem. Use what you've just been given to draw something that makes sense. He's on the edge of a building, so here he is. And that spot is 60 feet up in the air. That's what we know so far. And he throws a ball upward with an initial velocity of 68 feet per second. So here's what he's doing. He's throwing a ball, goes up in the air, and it's going to come back down. Follows the same shape as a quadratic function. The ball will eventually hit the ground. You have to figure out what is the maximum height reached by the ball. After how many seconds will the ball reach its maximum height? And how long will it take the ball to reach the ground? What units will we be using to solve this problem? Feet. And then, what information from the contextual description do we need to use in the function equation? Well, first of all, we have to write the function, which is h of t equals, and since this is in feet, it's got to be negative 16 t squared plus. The next part of the function is velocity. What was the velocity that I showed you in this problem? 68 feet per second, so 68t is what we put in. And at what height is he starting out at? 60, so we put the 60 at the end. That's all of the information we need from the problem in order to answer several questions. To the notebook paper we go. And here is the function that represents Chris standing 60 feet tall on a building and throwing a ball into an air, and the ball comes down and hits the ground. We have to find the maximum point reached by that ball. You're going to have to complete the square to do this. So we must group these two together first, because there is a negative 16 next to the t squared, and we have to factor out that negative 16. When we do that, we have a negative 16 on the outside and a t squared here. 68 divided by a negative 16 is going to give me a negative result. That's why I'm putting a minus sign in the middle. 68 divided by 16 is going to give us a decimal, obviously. So let's just hold that off for now and put 68 over 16, t, space, and then a plus 60. We need half of the middle term. As luck would have it, it's a fraction. And on today's quiz, one of your questions was, what do you do to a fraction when you divide by 2? Double the denominator, that's right. Multiply it by 2. So instead of 68 over 16, half of that would be 68 over what? 32. And then we have to do what with it? Square it, yeah, as part of completing the square. So we have to square 68 over 32. 68 squared is 4624. And then 32 squared is 1024. But I have not added 4624 over 1024. Notice there's a negative 16 out there. What I've really done is negative 16 times this fraction, which gives me a negative result. So I've really subtracted something. Now I have to add something on the other side. And I'm running out of room here, so I'm going to put plus. What I have to do is the positive version of 16 times this fraction. When I multiply an integer by a fraction, do I, A, multiply that integer by the numerator, B, the denominator, or C, both? A, just the numerator. So 16 times 4624 is going to give me 73,984. The denominator stays the same. The last thing to do is to put it into a form that we can use and extract information out of. So we have our negative 16 out to the left. Parenthesis, use the variable t, the sign from the middle, minus. Half of 68 over 16 is 68 over 32. And then close it, square the quantity, and then simplify this. out here with your calculator. Do the division first. 73,984 divided by 1024, and then add 60 to that. And it will be plus 132.25. Now we can get some important information out of this. What is the vertex of this? Yes.
68 over 32.
Oh, well, 68 over 32, that brings up a good point. We cannot take information out yet. We have to do what with 68 over 32? Divide, yeah. So 68 over 32 is 2.13. I think that's a little more useful to have that. Okay, now that we have it in a usable and readable format, what is the vertex? Yeah.
132.25.
That's right, 2.13 and 132.25. What does 2.13 represent? How long it took for the ball to do what? Maximum height in what units? Feet, but in terms of time. Seconds, yeah. So that represents seconds. And this represents what units? Feet, yeah. All right, so it reached its maximum height at this amount, 132.25 feet, and it took it 2.13 seconds to get there. Now another question that we have to answer is, how long did it take it to come back down to the ground from the time that it was thrown? We don't have time for that today, so we're going to pick up where we left off tomorrow, part 2. And we'll even review this equation again tomorrow and then go further from there.